Troubleshooting yard lights is a recurrent activity around here. This one is a General Electric 150 watt high pressure sodium fixture. It accidentally got hooked up to 220 volt circuit and it's a 110 volt fixture. You can see the mogul base socket that takes the large envelope bulb. As I turn it over, you see where the photocell plugs in on the top of the fixture. This white plastic cage holds the starter components. There's a diode missing that I clipped out to search for a replacement. Then you see the transformer, or what is often called the ballast. Let me turn it over again to show the terminals where the supplier wires get connected upon installation. If you have voltage to these two terminals and the light doesn't come on, first, most obvious, put in a known good bulb. Then generally you try a new photocell, but keep in mind that photocells generally fail with the light on all the time, because when the photocell works, the light causes a decrease in resistance through the photocell and the current flow creates a magnetic field that pulls the switch open. If you can eliminate the photocell, then try the starter if you can get one. Most vendors just want to sell you a new fixture, but the starter can be acquired if you dig a little. If the starter doesn't fix it, and you haven't found any broken wires or bad connections in the process, then you can try the transformer. Again, it's not easily available, and they seldom fail. When all else fails, you'll have to bite the bullet and pony up the cash for a new fixture, and they're not cheap. Let's trace through the operation on the schematic. Current flows through the photocell contacts if it is dark, then through the ballast to the starter circuit. No current flows through the bulb because it presents a high resistance when it's cold. As current flows through the resistance and inductance of the starter, a magnetic field builds around the ballast. When the AC cycle reverses, this field collapses and produces a high voltage spike. The choke in the starter forces this very short duration spike across the lamp terminals, and the capacitor in the starter absorbs any excess energy. Once the lamp lights, it presents a low resistance path for current flow, and no current flows through the higher resistance of the starter. The magnetic flux continues to expand and collapse around the ballast, but no spike is produced because the relatively high resistance path through the starter does not allow for a rapid collapse of the field. While troubleshooting in the field, you can only really measure the voltage at the input terminals to the fixture. If you attempt to measure across the lamp terminals, the voltage spike may damage your meter. If you have input voltage, then a thorough physical inspection on the bench and swapping in known good parts are your only recourse.